Welcome to Emergent Behavior, where we explore this moment in time just before artificial intelligence changes the world as we know it, where we talk to the builders and creators, entrepreneurs and engineers, where we ask questions to which we don't actually know the answers to. I'm your host, Prakash Narayanan, known on Twitter as AdaPi. Hello and welcome to Emergent Behavior. This week I have Justin Lin from Alibaba's Qwen team. They have just launched Qwen 2, an open source LLM that beats Meta's Llama 3 on many benchmarks. Justin has held various roles in the Alibaba team over the last 4 years, including tech lead, and he is currently the chief evangelist officer for the Qwen project. He is also a master's in linguistics from Peking University. Language models has been his core focus for almost 10 years. I'm also joined by my guest host, Eugene Cheah, the CEO of Recursal.AI, the company backing the RWKV open source project. He is joining me from Singapore. Justin is joining me from Beijing, China. And we get to hear exactly how the Qwen team thought about building this new LLM. In this episode, we're going to cover the critical role of data in training large language models, how the Qwen team is meticulously curating data to improve coding and multilingual capabilities, the unique challenges of building language models for Chinese, including dialect variations and data access limitations, and the future of the Qwen series and how open source innovation can drive progress in AI. Justin's experience building and deploying large language models in the real world, combined with his deep understanding of the challenges, make his perspective truly unique. He's not just a model builder, he's shaping the future of AI accessibility and pushing the boundaries of what's possible with language technology. This episode is a must listen for anyone interested in figuring out how the development process of language models outside the US and outside the San Francisco bubble really are, what model builders are looking for, what their learnings are, and how quickly they are catching up to the state-of-the-art frontier models which are being published in the US. You're going to gain insights on the complexities, challenges, and the different kinds of data and the exciting opportunities in open source innovation. Without further ado, let's jump into this conversation with Justin Lin and Eugene Cheah and explore the fascinating world of open source models with Qwen 2. And as always, if you enjoy the show, the number one thing you can do to support us is to follow Emergent Behavior on Apple Podcasts. Every follow massively boosts our reach. You can also subscribe to our newsletter at emergentbehavior.co to stay up to date on all our latest episodes, including my research and preparation notes for each podcast. And you can find me on Twitter at numeric8, TEAPI. So, Justin, what is Qwen 2?
Yeah, hi everyone. Yeah, it's my pleasure to introduce. We usually call it Qwen 2. Yeah,
Qwen.
yeah, right. Like to call it, make it once now. Yeah. Well, Qwen 2 is the new model of our Qwen series. Qwen is previously a large language model series. Actually, we have some multi-model, but we do not include it today. Qwen 2 is the new series. And for Qwen 2, we include base language model and instruction-tuned large language models with 5 sizes ranging from 0.5B, a very, very small one, to a large one like 72 billion. Yeah. We have some benchmarks. You can check our blog. We have some benchmark evaluation. You can find that our Qwen 2 72B can outcompete Llama 3 70B. I think they are at least competitive. If you check today's Chatbot Arena score, it has some new scores. We are around 1,190. And like Llama 3 70B, it's around over 1,200. Yeah, it's somehow competitive. So I think people can enjoy it. This time, in comparison with previous like Qwen 1.5, we have some improvements in coding and mathematics. In comparison with Qwen 1.5, it has improved quite significantly. And this time, we have paid more attention to multilingualism. So we have specifically paid attention to over 27 languages, except for uh, English and Chinese. I think the model can generalize well to more languages, but for what we have done, it's around 27 languages. So I think if people use it in other languages, especially those in like Western European languages and in like East Asian languages like Japanese and Korean, they will find it good. Yeah, yeah. Generally, it's just like that. A very simple introduction of Qwen 2. Yeah.
So just give me some background here. Like, so the Qwen series has been has it been in development for like a year, more than a year in Alibaba? Like when was the 0.1 or 0 kind of like first start, and then like what has been the process since then?
Yeah, we have been developing it for more than a year, around 1.5 years. And our first
Right.
release is actually in April last year, but a lot of people don't know about it because it was just released in mainland China. And then in August last year, we tried our first open source, Qwen 7 billion, and then we accumulate some experience through this process. And then when it comes to November, we have Qwen 72 billion, and this might be the first time for a lot of people to know that yeah, another company, another group has a very, very large model. Yeah, competitive to 70 billion. Yeah, for a long time, we do not have another competitor to Llama 2 70 billion. I think this is the one. And then when we come to the next iteration, we solve a lot of a lot of problems inside the previous series because previously we did not have enough experience, so the models might not be satisfactory for a lot of people. But for Qwen 1.5, we then have a lot of developers, and that's why you meet me in yeah Alex channel, and somewhere else because there are becoming more and more people using it. But this time we have used uh, totally new data for the pre-training because everything is actually about the pre-training. If you have done pre-training quite well, and if you use a standard recipe for post-training, you can still achieve a very good performance. And this is why we released Qwen 2 because we have invested a lot in the pre-training for Qwen 2. Yeah.
So tell me a little bit more about the pre-training data. Like how has the data mix changed from 1.5 to 2? How did you think about this whole process of acquiring data? Like what are the key things that you guys did?
Yeah, that's a very good question because when we first start to build large language model, what we are thinking is that we hope the model can model uh, the distribution of human knowledge. It is
Yeah.
a bit abstract, but this is somehow what we are going to do. But it's really hard. You can collect a lot of data from the web, but actually there are a lot of noise. It does not mean that
Mm.
your collection from the web means that it is somehow like human knowledge distribution. It is somehow a bit ridiculous. And for a long time, we don't know how to figure out the best way to do it. But
Mm.
and then actually, it's more about engineering. It is not that kind of sexy for for a lot of for a lot of people to imagine that wow, you might have some tricks, you might have some magic inside it, but actually it is not. Uh, we try to use small models to do the data curation experiments. This
Mm.
is why we had 1.8 billion, because at that time, people are curious that why are you open sourcing a 1.8 billion parameter model? And then people find it, well, it is so good. You can run it in your cell phone. And then we have zero point 0.5, and they will find it, wow, it is so small, it is good for testing or something like that. But for us, we do not do it intentionally for this purpose or for the devices. We just do it for the data experiments. Because for small models, you can investigate a lot about data scaling and about how your combination of different sources. So you do a lot of experiments and find a good recipe for it. And this time we have, because when time goes, you can have a lot more data. You can have a lot more higher quality data, and this is very natural. And we try to do some ways, following some recent progress. So how to improve your coding capabilities, because if you do not intentionally to crawl data for coding and mathematics, you you may get a lot of crap data for it. You need to pay attention to it, how to crawl the data from the big data set and crawl the coding specific data, and then you can check the data if it is qualified, and how to improve the higher quality coding data by to improve its quantity. So if you have done these techniques, you'll find that the model performance is improving very consistently. With the
Would you
with
say
your
so, would you say like one example would be like the first time you do it, you just crawl all of like some coding resource, I don't know, like GitHub or whatever, whichever is public. And then the second time you do it, you're like, hey, let's just do that, but let's discard all of the bugs that you have in the code base, and let's not like crawl the bugs this time. Is that one way to look at it?
it is. I think you are somehow you are right, because previously, if you do not pay attention to it, you have some coding data inside it, but it is a very low proportion. So you will find that it can code, but it cannot code that well. If you put too much coding data inside the pre-training data set, without processing it very carefully, you'll find that the general language capability drops drastically. So this is previously we have suffered from this, and we do not know how to balance these things. And then when we come to the next iteration, we have a lot of coding data, and we try to see that there are a lot of data inside, like GitHub. They are actually not that kind of related to coding. You need to remove those irrelevant data very carefully, and then you have some very precious data, but previously you might think they are noises. Now the commit data. For the commit data, now people know that because of I have another project called OpenDevon. Now people know about Devon. They know the commit data might be very precious. For the training
Why
of the
is the
model.
commit data so precious?
Yeah, because it somehow reflects the process, how
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 people think.
yeah how people think about the code and how people fix the problems. And what is more significant is actually the trajectory of people reasoning. For
Mm-hmm.
example, if you would like to label an instruction tuning data for like how to fix a bug inside a GitHub repo, it is actually somehow hard, because you need to check the repo and see how many files are in there, which files, and what content is there, and you need to have a planning. So what's the step to do? First step, the next step, what it is. It is a bit complex, and you have an interaction with the environment. So
Mm-hmm.
you can find that if you would like to collect these data, it is kind of quite difficult for the instruction tuning. But based on this, you need to learn a lot of these similar data in the real world in your pre-training, because you would like to inject a lot of knowledge inside the
Mm-hmm.
pre-training, and you align it with your instruction tuning, with your careful labeling. So
Mm-hmm.
this is what I'm talking about. If you do not have enough good data, like commit data, you cannot align the model to align to with human trajectory for fixing a bug, somehow like that. So there are a lot of these detailed experience.
Yeah, I can add into that actually because other teams have also explored similarly when trying to do the coding agents, open devins or and what so. The main goal of adding commit data is just more of like to show the before and after process when trying to do certain tasks. Because if you just take the final commit, you're only getting the final copy, and you're not getting the before and after process as the model goes through the coding process. Yeah.
So let me just kind of thought experiment. Yeah. So you have guy wants hello world. So he goes there, types in hello world, and then of course nothing happens. So then he does a commit, and he's like, oh, print hello world, and then okay, so now it prints. So now when you put this into the pre-training data, you put in both the first commit, which was just the hello world, then the second commit, which was the print hello world, right? Now, do you put in both commits, or is it like a trajectory, as in like you put in hello world and then commit first commit hello world and you label it as a first commit, and the second commit print hello world and you label it as a second commit, and then you send in both the first one and the second one so that it has a history of both what actually happened. But it's in the pre-training, it's all just tokens, right? It all ends up as tokens. How do you connect these two results, right? How do you connect these two pieces of data in the pre-training, or is that something that you do in the alignment in the RLHF in the instruct tuning later on? Like how does this work?
I think your thought experiment is very interesting, and for the pre-training data, which means that if these data are very valuable for aligning it with the trajectory, so maybe from the appearance it is somehow not redundant, but actually it is quite important for the alignment. And if you have learned these things, your alignment will be relatively simple, just with some samples. For example, 10 samples, you can align it with such kind of capability. But RLHF is another topic. But if you have not learned these things in your pre-training progress, because it costs compute, you cannot have these capabilities when you align it, even if you have very high quality trajectory labeling data. So this is what we are thinking about. So we can have many such kind of examples. Yeah. Another example about improving the coding quality is that we used to ignore a lot of coding data in some programming languages that we are not quite familiar with, because there are a lot of data they are actually in Python, and naturally you will think that when you process these things, your filtering rules and even your model filter, people use models to filter the data. Even your model will bias like Python data. This is just an example. Yeah, but this time if you have tried with some more data in more programming languages, things will be better. Yeah.
Amazing. So it sounds as though there's like a lot of these like small data plus alignment like experiments that you need to run in order to get like a recipe for the final model. Is that a one accurate way to put it?
I didn't quite get the question.
It sounds as though you have a lot of these like small experiments that you need to run on, like
yes.
Data recipe plus what you want in the alignment, the objective of what you want to construct, and how you create a data set in order to get to that objective. Is that an accurate way to put things?
Yeah, that's a very, very good question. And we have a principle. It's somehow like evaluation is all you need. Yeah. If you do not
Evaluation is
have,
all you need.
I somehow read this sentence from Greg Brockman's Twitter. I'm not pretty sure, but when we find this thing, we would like to say evaluations are unique. Because if you do not have evaluation, what you have done is somehow meaningless because you don't know where the goal is. Yeah.
Right.
For example, you have even if you're a small team, you have two different groups of people. Some people are working in pre-training, some people are working in post-training, and
Yeah.
the post-training suffer from stress because if the model does not work well, people will blame the post-training team in the most cases. It was you can always find a lot of bad cases inside your instruction tuning data.
Right.
You can check. You just sample something and you'll find that well it is rubbish. Why didn't you find this thing? But people just don't know. Well, maybe you have some quality problem inside your training. Yeah, this is our bitter lesson, and it is somehow brutal to evaluate the pre-training data set. We are actually using benchmarks, but we try to use more benchmarks for us. Not just one. For example, not just MMLU, but we use multiple, and we check it for multiple steps to find that if it is increasing very stably. If it is not increasing stably, there might be some problem inside the data curation. So if you have some evaluation, you will find that it is so good. And you need to have a pipeline, or you need to have some guy for evaluation that is very, very, very smart. He knows how to build a system because he has a pipeline and he is responsible for all the groups. And you need to make sure that your evaluation for the pre-training model is at least positively correlated with the post-training evaluation, so that you can find that for the pre-training team, things are easier. They just look at the benchmark score and they believe in it, and the post-training team believes that if they are doing a good job in the benchmarks, we'll do a good job in our post-training. So they will be separated, and then
so
this is how we do.
Like for example, do you test like MMLU on both the pre-training and post-training? Is that like some kind of thing that you do?
Previously, we do not test quite a lot in instruction tuning because I think instruction tuning is not targeting for this. But I don't know why now. Very recently, people pay attention. Pay a lot of attention to it. Yeah.
I can add some comment to that. So I think I also didn't introduce myself to the public as well. So I'm Eugene. I'm from the RWKV group, which is another group that also do open source foundation models. Mostly into the sub-quadratic space. So we are looking into trying to solve the quadratic cost problem, respectively. And we actually have some similar statements as well. We have the loss curves and eval. Will decide which model or decision will move forward, especially when we have competing ideas and theories. And most of the time, it's either loss curves. First the loss curve, then the eval will make the decision. And I think one thing that was interesting is that there actually have been an evolution regarding pre-training and MMLUs, or even running that at different stages. Like if you went further back to the PAL-based era, most people actually run their evaluations towards the end, and then they rely first on loss curve, and then we a lot of groups starts to realize that hey, if you include some high quality basic instruct data, or even let's say textbooks, all you need different teams will have different opinion, but the idea was that if you include more of this data in pre-training, the model will perform better in overall. So we started testing MMLU during pre-training as well. But then subsequently, we used to say, instruct is just more for alignment. But groups started doing instruct tuning with a lot of, let's say, textbook data. And that started boosting MMLU scores. And that suddenly became a race, and this happened during Llama 1 and subsequently Llama 2, all the fine tune. Or the instruct tuning were like fighting with each other, boosting the scores respectively. And 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 that you can even see some instruct tuning arenas respectively. So subsequently became a norm for instruct tuning to also do the eval scores. So now you kind of do the evaluation at every single step, but different groups may have different decisions of what they choose to evaluate. Or in some cases, sometimes it's also a resource constraint because like for example, for us we run like a handful of eval during the pre-train, but for the final stage we run like 180 evals. But running 180 evals can take a lot of hours to run respectively. So it's not necessarily worth it to always run it.
So
I think also another thing that
you can't do this like continuous integration style of like every single change you make, you run the evals again, right? You can't afford
you can if you're open AI and Facebook because you have unlimited H100s. It's back it's back to the compute budget. So I think one thing I was glad to hear, right, is that because you might find this is like the philosophical difference from open source group and extremely well funded commercial group. Like it was previously mentioned that like other open source group, we do small models first, 0.5, 1.5, 3, and 7B, mostly because we want to test with our limited GPU budget. We want to test with our cheap GPUs, 3090 or 4090s, before we commit the H100s, which cost way more. And larger research groups will be like, yeah, we go straight to 7B. Or we go straight to 70B sometimes. I met folks at Google who like, yeah, they only test at 20B and up because they don't want to waste time on the smaller scale. But they can do that because each member of the team has dedicated H100s. So it's a compute constraint as well. Yeah.
I think everyone might still have the GPU poor problem, even for the very, very rich one. Because when you have more GPUs, you always would like to build very, very large models. So
it's just a different skill.
Yeah. For example, if you have like 10,000, you would like to put the 10,000 GPUs into one model to test that if this model scaling really works that well. But this is somehow everyone has this kind of problem. I think it is very very good for people to test things on small models at the beginning. 7 billion. Actually, I remember at the beginning of last year, we are actually using 7 billion. And then we find that we are just so stupid because you do not need to use such large model to do the data experiments. So when we find that we use 1.8, it is quite good. We can do, 10 times more experiments of data curation. You can make the data much, much better. Yeah.
So
Exactly.
just to give me some sense of like scale, right? Like 7 billion fits onto A100. Is that right? Or like what are these sizings like 0.5, 7 billion? Like the sizing parameters are around like how much memory the chip has, right? So what are the sizing parameters kind of match like in terms of chips?
I think training is a bit is quite different from the inference. When you are talking about inference for BF16 or FP16, you can just imagine that for 7 billion, it will take up more than 2 times, a little bit more than 2 times. You can run it. So, for example, for 7 billion, you can run it on 16 gigabytes
16 gigabyte
GPU. Yeah, 16 gigabyte. It's okay. Yeah. But for training, you have a lot of concerns because you need to see that how many tokens you would like to train and how many GPU hours it would take you to train the models. And for 7 billion, it would take up actually quite a lot. 7 billion is actually a large model. Yeah, from the data perspective, at least from the data perspective. Yeah,
I see. Right on.
I'm not so sure about the your group, but actually our group, right? The biggest constraint has always been training on single nodes. So for most of our experiments, except for the big jump, right, we only train on single nodes that could be 8 GPUs or 4 GPUs. And if you train 7 billion, some of these experiments will take days. So the reason why like 0.5B and 1.5B usually is the bulk of our initial experiment is because we want it to run in hours. And so that we can say, hey, this worked, this failed, let's go to the next size.
Oh, I see. Yeah, for single nodes, it is a bit painful. We are using multiple nodes, and even for you to train it with like 0.5B, you'd better use like 16 or even 32. Yeah, like A100. That would be good because if you would like to test the data, you have to train at least hundreds of billions of tokens. Yeah. If you just train like 1 billion or 5 billion, it is somehow meaningless. So this is how we do it. Yeah, we are training with multi nodes. Yeah.
Right on. Little bit more on the data. So one of the concerns that I see often is that the benchmark evals are leaked into the training data because we discuss them so much. They're published everywhere. Like everyone's looking at them, and they're duplicated so many times in the training, in the scrapes. So how do you get through this process of like, the test data is already in the training data set? Like what do you do? Are there ways to prevent the contamination? Like how does that work?
Yeah, we are actually quite afraid of contamination because it when people find the contamination, we just did not intentionally do it, but it is not that good. We usually use like 10 grams or 13 grams to filter the similar data. You need to
So
pay a lot of attention.
n gram meaning like number of tokens which are the same tokens matches, and then you search. So 10 gram or 15 gram meaning 10 or 15 like continuously related tokens, and then you kind of match, right?
Yeah, generally you can imagine it like that. Gram is a bit different from today's tokens because token is about the subword tokenizer, but you can imagine it.
The gram is a different kind of token, right? A different kind of tokenized.
Yeah, but for today in the pre-training model, I don't think this one is the most significant problem. I think there are a lot of similar data which is not in the test set, but they are actually inside the pre-training data, and this is something that we cannot test. Yeah.
So, for example, it's like in the test set, there's like 1+1, and you manage to discard all the 1+1s, but then there's a 2+2 inside the data anyway, and that teaches the thing the same, like kind of very similar thing, like kind of perturbation or whatever. And then you have the problem that it's already in there somehow.
Yeah, and then it comes to me another question is that is it really bad for the large language models? Because if you have a lot of like the work file, there are a lot of textbook data into it. If you put a lot of textbook examples into it, there are always a lot of similar cases, similar to the test cases. So this is what we are worrying about, but somehow I think it is generated, at least for MMLU. For MMLU, it is really, really hard to surpass like 80. It is really, really hard if you do not train with enough tokens. So we keep trying using the data set that are really helping us to improve the model quality because we have a long pipeline, not just MLU. MLU is somehow, maybe for a lot of people, it is something to brag. Yeah, you are very good at MLU, but that does not mean it. That does not mean everything. Yeah, even for the instruction tune model, we believe some alignment dataset and some instruction following dataset more. For example, for the instruction tune model, we will pay a lot more attention to Empty bench is okay. Empty bench is quite small, but I
Yeah.
think it is aligned with human preference. Generally, well, today we have some new things like Arena Heart and Align Bench, and if eval is also good. If eval is testing the instruction following capability, and
Right.
through the process, we find that Qwen 1.5 has a lot of problems inside in instruction following. Yeah, even Qwen 2 has some, but it greatly alleviated. I think that this is something I admit may be lagging behind. Like Llama 3 70B. I don't know how they do it, but good evaluation will always help us to reach the goal. And the next step is human evaluation. And we always have a human evaluation. But after the long pipelines, we do not have many models left because a lot of models are filtered. For example, we have when you instruction tune models, you can just use one single node to train a instruction tune model, and then you will have a bunch of instruction tune models like every day, every week. But you need to filter it not to pass into human evaluation because human evaluation is so expensive. Yeah, and and then and then another thing is you can check Arena. Arena is somehow good, although I think the users are a little bit biased because there are a lot of users that are actually using large language model. They will never test cases on Travel Arena, but
Right.
at least Travel Arena is somehow today's best benchmark. Yeah.
I see. I see. Um, let's talk a little bit about the multilingual capability. So I came across QN, I think QN 1 or 1.5. I came across because I spoke to someone in India who was doing a farmers like application, and they were serving in local language, and they found that QN was the best. Even the 1 or 1.5 version was the best that they could have for Indian local language. So they ended up using it,
Wow.
and so they're telling me about it. So
Wow.
how
That is so
how
good.
do you how do you guys think about, like, the language capability? Like, how does that work in terms of like acquiring the data set and like putting it together?
Yeah, previously we did not pay attention to this thing, but actually, if you collect data from the whole web, you will have a lot of multilingual data. Yeah,
Oh,
inside it. For example, if you check the public data set for the English, there are a lot of Spanish in it because there are a lot of people speaking Spanish in the United States. Yeah, that's quite
mhm.
reasonable. And there are a lot of people using French, and so you might have a lot of French data into it. So if you check even like Lava, it is actually quite good at French, but I don't think they pay special attention to yeah to French as well. And previously, we also do some similar things. We find that it has good potential to become a multilingual model. For Qwen 1, we paid almost zero attention to it. And for Qwen 1.5, we have some guys for the evaluation. They test the base language model, which is not the instruction tune one. They will find that, well, it actually performs quite well in some benchmark like MGSM and MMLU, like multilingual MMLU. So it might be good potential to become a good instruction tune model for multilingualism. So we just ask the annotators to help us annotate some instruction tuning data in other languages, and we find that it is aligned quite well. So for this time, we try to invest more into it. Yeah, if you pay special attention to it in some languages, yeah, you will improve it for sure. Yeah, not that hard.
So one thing I noted for OpenAI when they switched to the 4.0 was that they ended up with a new tokenizer to do, and mainly a lot of it was to do with like addressing other languages, because other languages often you had this enormous amount of tokens that needed to be used for like Korean or Russian or whatever. Is that something that you see? Like, did you guys have to play around with the tokenizer in order to get kind of better performance on a per token basis for multilingualism?
Mhm. Yeah, sure. Tokenizer is actually very important. we might be some of the first teams that are using tick token, and there are a lot of people that they are not using the BP the traditional BP tokenizer with tick token. We are just using tick token. I remember that we are based our tokenizer on CL100K, if you remember, GPT-4 tokenizer, and then we expanded for multilingualism. We pay a little bit more attention to Chinese because we are now in mainland China. There are a lot of Chinese people using our models. We pay a lot more into it, and then we try to pay more attention to some other languages we are somehow familiar, like Japanese, Korean, and some Southeastern Asian languages. Yeah, it's just like that. Then we have a tokenizer with around 150,000 tokens. It is actually a large one. But today, if you check today's models, like DBRX, they are following using tick token, and then for Llama 3, they changed from the sentence piece tokenizer to the tick tokenizer with a larger vocabulary. Yeah, previously a lot of people are suffering from the sentence piece tokenizer and with a small vocabulary. You need to expand it. You need to pay a lot of attention to it. But if you are using our tokenizer or today's Llama 3 tokenizer, I think problem is solved. I think OpenAI is marching a step forward. But there are some problems inside their tokenizer, especially for tokenizing Chinese. I don't know what happened.
So I heard that
cases.
I heard there was like a lot of like Chinese porn related things inside the tokenizer.
Yeah, I think the tokenizer guys may use some noise data to train the tokenizer. Yeah,
I'm quite sure they didn't get any native speakers to check it. That was the problem. They just just build it, never double check it.
Yeah,
it is actually very, very hard to check the tokenizer because it is something at the beginning. If you launch something, you cannot stop it very easily. If you go back to it and almost everything are reverted, that is quite horrible. Yeah.
Right. So you kind of live with the mistakes for like one generation, I guess.
Yeah, we are a bit lucky because the guy who decides the tokenizer is very intelligent. Yeah, in our team. Yeah, we always trust the intelligent one.
So I've gathered that like one other thing that I've noticed is that your the Qwen2 pays special attention to code switching, which is unusual. Yeah. So can you talk a little bit about that?
It's a very interesting phenomenon happening in Qwen 1.5, annoying a lot of people, and even when we are ourselves are actually using it. This is something when we find it after building it. Yeah, if you ask it to translate something from Chinese to English, it will generate some Chinese characters very ridiculously. And the Chinese characters or words are actually related to the content. It is actually not nonsense. So this is somehow a bit strange. We try to figure out the problems, but it is a bit hard because there are a lot of code switching data inside your pre-training data set. You cannot remove it drastically because they might be very important. For example, they are just pairwise translation data, and there are some noise into it. You cannot just remove it because of a little bit noise. They might be high quality data. And for the instruction tuning, if you do not pay, if you have trained it with multilingual data, if you do not pay enough attention into multilingualism in your instruction tuning, you will have some strange phenomenon. I think this thing is actually also happening in some API models. I remember it in Gemini. Gemini used to generate a Russian word, very abruptly. I don't know why, but today they might solve the problem well. It's all about data. So this time for Qwen 2, we have also invested more efforts in the instruction tuning for multilingualism for a lot of languages, at least we can do for it. We can do for too many languages. We try to check the code switching. We just use some prompts. We just use some prompts that will often trigger some code switching phenomena, and to see that whether the proportion of code switching is dropping. Although there are still problems, especially for small models. Large models are quite well, but for small models, you will sometimes meet that. Yeah.
Right. So maybe to put that in context, it's like, okay, so some native speakers might do this thing where they speak in English and then they have one or two words in Chinese or whatever other language, and the model should know when to respond with kind of a mixed language, and when not to respond, when to be monolingual and when to be have that code switching in there, and it should be in the right context. So I guess in the instruction tuning, it's basically taught that hey, if the guy's persistently in like business English, you shouldn't do the code switching. But if it's maybe like colloquial and he's mixing it up, then you should mix it up too. Is that a good way of putting it?
I'm not quite sure about that, because the code switching problem is a little bit unexpected. It is not something very natural, code switching. Yeah, it is a bit strange. Yeah.
I think he's referring to the more drastic code switch, like from English to like the example, like all of a sudden Russian appeared. That wasn't following a format. Unlike the situation where like in Singapore is quite prominent for this. We have a variant called Singlish, which includes a little bit of Chinese, a little bit of Hindi, a little bit of Malay. So that's not really code switching. That's kind of like a cultural subset language.
Yeah.
So that's a different situation altogether. But I think he's referring more to the more drastic one, which we also have observed before, like on smaller models. And I think on model size, I actually always wanted to ask this: why 72B in particular, instead of 70B? Like why do y'all choose to increase the MLP hidden projection size? Because that was something that was something I always wondered. Like since the previous Screen 1.5 is like it's clearly inspired by Llama's architecture, but that one piece of size was bumped up, and that was different. And it's like, why? I never got to find out why.
Yeah, it starts from we have larger vocabulary. Yeah, if you compare with Llama 2, and we try to count it by our calculation, but it is somehow like if it's just a little bit more than like 71, it is a bit strange. So when I make the number that looks a little bit better, we usually increase the MLP part. Yeah, increasing the MLP part is always helpful. But you need to choose a good size, at least for quantization. It should be the times of like 128 or something like that. So when you do these things, and well, it just happens. This is something that happens. It starts from larger vocabulary, and then it happens to be like 72. We did not really intentionally to make it so different, but we don't think that will cause too many problems for users. I'm not quite sure, but I think it won't cause too many problems for users. Previously, we have caused users some problem. It's our 7B model. We have larger vocabulary, and then our size is actually approaching 8B. And people hated our model because it is 8B. You cannot fit it into a 16 gigabyte chip. Yeah. And then this year, we had Llama 3 8B. And I don't understand. Yeah. We have Gemma. Gemma is also 8B. I don't understand. Because people are complaining about us approaching 8B. It is not good. So we are reducing the size to closing to 7 billion. And then today, people are talking about 8B and even 9B. I don't know, but
is that because there's some improvement on the memory somehow, or is that the chips have like
No,
additional memory
I
now, or is it what's going on? Like,
I don't think so. If you are using 16 gigabytes, for example, if you are really approaching 7B, yeah, you will have another like no more than 2 gigabytes for you to put your KB cache.
yeah.
You need some you need some context length. You cannot just put all the model weight into it. I think the previous GLM 6B is actually a good size for a lot of people because there are a lot of buffer for the 16 gigabytes. I think it is because of the competition. Is yeah, it is so competitive. But yeah,
I think it's competition, but I also think it's might be a case of a vocal minority being over amplified. Because for most people that run 16 GB, they are most definitely
yeah,
quantizing. Because like you say, if you have such a little overhead, right, all you can do is like 1K, 2K context length. It makes the model really hard or impossible to use. So almost everyone quantize if you have a 16 GB of VRAM. And once you quantize,
yeah,
you have enough space regardless of 8 GB or 7 GB. But there are folks that wants to do benchmarks and tests, folks like me,
yeah. Sure,
who
yeah, sure.
insist on running in BF16. It's like, I always want to test in BF16. And for me, sometimes when that happens, that becomes annoying. But it's not, I'm not going to go on the internet and say, why do you make it 8 GB instead of 7 GB? I'm not going to like, no. But there'll be someone out there who particularly didn't like that.
Mhm.
And then it become a very strong amplification. So I and I actually did notice that at some point in time that there was a very strong push towards like, oh, quantization make the model worse. We shouldn't quantize the model. Then people started quantizing harder and harder and more dramatically. Like they quantize like 70B to
Yeah,
Q4. There are people quantizing to 1.5, no, 2.5 bit. All those extreme quantization, and then suddenly you hear less people talking about, hey, we must, you shouldn't quantize. So there always been that back and forth, and sometimes I just think it's the vocal minority that just got amplified. Don't worry about it. Really, really.
yeah,
I
yeah,
was
yeah.
asking
I agree.
why you do 72. It's just a curious question. Because at the end of the day, right, it's your model. Put whatever
Yeah,
number you
sure.
want. Especially when your team and your company is the
Yeah,
one
sure.
paying the bill for it
Yeah,
and for the training.
Yeah, go ahead.
yeah. When you decide the number, it is always very hard. And previously, you do not have enough experience, and you will have some new number, and you do not pay attention to it, and then it will become like a culture. Yeah. For example, when people are talking about 72B, you know that they are talking about you. And if you suddenly become what Quen to 70B, well, they might not get used to it. So for Quen 2, we had a little bit more concern about this number. But for Quen 1 and 1.5, we do not really intentionally think about it. Yeah. This is very interesting. Yeah.
I mean, we're also guilty of it. Like our 7B model is technically 7.1 or is it
Yeah.
7.2, but then we just quit 7B because it's just
So
Yeah.
easier for everyone to
let
say.
me let me let me let me expound on this a little bit. Like, so what happens when, like, how much has Quen 2's development been driven by comments from users and requests from users from the last version? Like, how much of this is a kind of iterative process of learning what the market wants?
Yeah, for the sizes for the open source models, we actually have some larger models we are cooking. That is another part. But for the open source part, there are a lot of sizes that are related to the request from our users. For example, previously we had 4B because we have some customers. They are trying to deploy the model into the mobile phone, and they are using 1.8B, but they do not find 1.8B is qualified for this. They find 7 billion is qualified mostly in most cases, and they can take the performance drop a little bit. So they would like something in the middle. They would like 3 to 4, and we cook the 4B for them. And for the 32, it is somehow like, well, you have 14. It is good, but not that good as 72B. But we can never afford deploying a 72B model, because if you deploy it in your company, you in most cases you might need at least 4 GPUs for you to deploy that one. At least two. But people usually use more than 4. It is actually
grand.
for some for some customers it is a bit too expensive. They were like in the middle. For 30B is actually a good size because there are a lot of people using E34B. It is quite popular because it is almost for a long time the only model at that size. If you quantize it to 4-bit, it is actually quite good. You can run it in a 24 gigabytes chip. Just run it locally. With 32, you can enjoy the model quality, but you can just use your local computer to run it. So then we have 32B. Following our computation. So it becomes.
So what about like specific things like coding? Like let's say someone says like, hey, it's not coding well in like Lisp or some other language. Have you ended up like, oh, okay, so for the next round you have a to-do list, and on that to-do list like improve Lisp like coding, and then like you go out and someone like some team member kind of like cleans up a little bit of data for Lisp, and then you implement in Qwen2. Is that kind of a process that happens?
It is similar, but a little bit different. When people are testing for coding, they have a lot of benchmarks actually. If you make it very simple, you just test human eval and BPP, you will find that it is actually low. So in comparison with other models, if you do not overfit like a simple Python problem, you will find that it is quite low. And then we know the problem, but we need to solve it. It is not something like, hey, you give me a comment and then I solve the problem for you. It is not like that. It is something concerning with pre-training. So we had another small team, a small group of people. They are experts in previously models for coding, and then they come to use large language models for coding, and they learn how to build coding-specific large language model. This is why we have CodeQuen. And for CodeQuen, at the beginning, we actually do not have a specific purpose for how it is going to be used, because apparently it is just like, well, it will become a plugin for people to write code, but why not make it a product? Why open source such model? But we try to build it, and then we accumulate the experience of how to build coding specific data set. It is actually quite difficult. You need to have a lot of tokens. Previously, we might only have, for example, 100 billion coding specific tokens. We might think that is quite a lot for a lot of people, just coding 100 billion. But today, if you really check the coding model, previously DeepSeek Coder, and today like Codestral and CodeQuen, they are trained with a lot more tokens, even trillion, just for coding.
Are there like any metrics that you use to kind of like measure like user take up, like number of Hugging Face downloads or GitHub down? Like what kind of metrics do you look at to see whether or not users are actually using the product?
A very good question. Months ago, I tried to visit the customers. Because in mainland China there are in previous months there are not quite a lot open source model in mainland China. A little bit sadly, not just like last year. There are a lot of competitors inside our countries, They're very good. ChatGLM, Bytron, they're quite good. But this year, uh, mostly we are still keeping open sourcing. So we visit the customers, you will find that they are actually using it, and you have the confidence. You can check the numbers, but the numbers do not really reflect things. We just try to feel how users feel about our model. Previously, we release our models, and then we check the feedback for a month just by talking to the developers. We have some group chats, we have Discord, and we are trying to talk to them, and then we'll find that maybe the model this time is at this level, and next time my goal is to reach another level. Numbers not that important for me, but maybe it is more important for other people. For example, the company may look at the metrics, but actually it is about reputation, yeah, or people's belief. You try to feel it. Yeah.
Right on. So one of the things that people always talk about is that how English, there's a lot of English data on the internet, not other languages are less. So can you talk about a little bit of like, what were the challenges for Chinese data set? Like, is the Chinese data set, do you feel that there are gaps versus the English data set? Where those gaps are is the quality, like we saw with the OpenAI, their scrape ended up with a lot of like random porn noise, like, like what kind of like differences are there in these data sets?
It it's about the quality of the web data actually.
Quality of the web
If you
data.
put away web data, if you have some other data, for example, books, they are actually very precious. I think
I see.
you do not need to say like, well, Chinese data is better or English data is better. That is not a little bit nonsense. But for web data, English is mostly the better one because there are a lot of people improving the English data, and
I see.
the Chinese web are developing not that long time as the English web. Yeah.
Right.
So this might cause some problems for cleaning, but we find another problem is that it is somehow a bit hard for you to judge what is good or bad. If you have set up some rules, you will actually filter many good data. So
Right.
you need to try to use some like some based on experiments. You choose some good data and bad data, and you try to train a classifier, and you classify these data, and then you label it good or bad, and then improve it generally.
Right.
Not just using your feelings about, well, this is bad, so I need to filter it. Yeah. You need to
Do you
try
notice,
with more experiments.
for example, like in English there is kind of like, you know um kind of like African American vernacular English, which is kind of a little bit more like informal. Then there's kind of
Mhm.
like this kind of, more formal business kind of English. Are there those differences in the Chinese language where you have colloquialisms and like slang and normal talk, and then there's like the official, like, newspaper talk? And how do the language models like deal with that? How do you deal with that in terms of like, instruct tuning?
Well, yeah, there are quite a lot, yeah, in Chinese web, because there are a lot of dialects in China. Not everyone is speaking the Mandarin Chinese. For example, another of my native language is Cantonese. Yeah, so for Cantonese people, especially those in Hong Kong, they are using quite different words. Yeah, so the wordings are quite different. So you need to learn about it. Yeah, it is very hard. But for some slangs, I think it might be good for like role play. Yeah. If you set the system prompt to make it speak language in some styles, you will find that if you train it with sufficiently large Chinese data, you will find that you will play like the models will play like a character or someone in the Chinese web. And that is quite interesting. But for some dialect, I think the problems are not solved quite well. For example, this time when we mentioned the languages. I'm not sure it is good to say languages. We do not include Cantonese because for me, myself, if I check it, I still find some problems inside Cantonese. Yeah.
So is that why you think there's no like? Go ahead. Yeah.
Is there? Yeah, I wanted to ask. Not including Cantonese, was that a data set
You
problem
mean
or was that an
Cantonese
intentional
problems
choice?
or
No, like you said, you didn't include Cantonese in as a data set. Was that because of the lack of data, or was that more of like just an intentional choice to omit some to just
I
simplify
think
the entire training process?
lack of data is a part of it. Um, we did intentionally excluding some data, not just from mainland China, because we need to focus on how we usually behave, and we did not include enough Cantonese data. And you need to pay more attention to Cantonese, but in comparison with other languages, I think Cantonese is a bit hard because it is mixing with uh, what our Chinese are usually talking. So it is hard to filter it. For example, if you have a language classifier, somehow it is very easy to filter to classify the languages. Yeah, we just
Do
did
you?
not do it quite well. For the next step, we'll do it. Yeah.
So is that? Would you say that that's one of the reasons? Okay, so a few thoughts occur to me. There's no like C4, right? Like C4 version for Chinese. Is that right? Like the common crawl, the cleaned up common crawl. Is there like that kind of common crawl for Chinese? Is that present? Uh, is there a plan to create one? Um,
Mm-hmm. For Common Crawl, you actually have a lot of Chinese web pages, but it is
Already,
very, very hard for you to clean it. And there
I
are
see.
some organizations that are doing these things to build public data sets, just like OMO did. OMO team built DOMA for the English community. And
Right.
like I remember it is Shanghai AI Lab, they are building a data set, just mimicking the building of
Oh,
Comcross C4
right.
for only
I
for
see.
just for Chinese.
I see. I see. Is there? Do you think also that there's some like difficulty now because a lot of like stuff that used to be on the open web is now done on like messaging and Discord and like all of these like non-open web like platforms?
Yeah, yeah. Actually, in China, we this problem is actually quite serious. I don't know if you know. We are actually using WeChat. There
Yeah.
are a lot of information, good data are inside WeChat, but people cannot access it. Yeah,
Exactly. Exactly.
except for Tencent, and there are a lot of good things, content. We have a popular app called 小红书, the
Yeah.
book. Yeah, and there are a lot of good contents, but it is somehow hard to access. So this causes more problems because I think there are a lot of good quality data in the English web. Yeah, people can access
Yeah.
it, but
Mainly,
there are.
mainly from people on the bulletin boards in the 1990s. So, you know,
Yeah,
yeah. So, yeah, indeed.
that is a
So,
problem.
yeah, yeah. Which is
The
also
old
tough because a
internet
lot of them are
before
weirdos. So,
Facebook.
so there's this thing where I think there's only 1% of the internet actually posts anything. 99% of people lurk. So the people who are in the 1% who actually post something are all like slightly mentally ill anyway. So, uh, so okay, so the team, how has the team development been? Like, did it start off with like just like 3 people, 4 people in a room? Is there like like several hundred people working on it now? Like, how has the growth of the team been over the last like 18 months?
Well, yeah, the team is our team is actually quite interesting. We are working in an open space. Yeah, we do not just have some rooms to separate these guys, we try to make them communicate more and try to make them do multiple things. Yeah, but they will group them naturally. Even if you separate them, they will group them group naturally, because there are always some people that will prefer post-training and someone prefer pre-training. But at the beginning, everything is messed up together. Yeah,
everything's messed
but
up
generally they will separate into groups. Now we have vision language groups, we have audio language group. They will generally separate, but we try to make them communicate together. So we just make everyone equal. We do not say I am the tech lead, you should follow me, but we try to say if you have a good idea, we'll follow you. Yeah,
I see. And like, what are the like big challenges now? Is it being GPU poor, GPU rich? Is it like hiring good talent? Is it finding the right people? Is it finding new ideas? Is it implementing or trying out new ideas which are coming out? Like, what are the big challenges? Super interesting. Like, I have learned so much, on how they thought about. I didn't like, so this idea that you have to align the pre-training and post-training, kind of like think about what results that you want in the evals, and like align both. And if you want something in the post-training, you have to like nail the data in the pre-training. I thought that was pretty interesting. So
It was I think one of the most amusing thing was that it was a slightly hot topic of mixing some like higher quality instruct or textbook data into the pre-training data, because for a period of time people wanted a lot of pure models, like PAL only models, so that they can do one-to-one compare. But I think that ship has long sailed away, because since then one of the issues is that the vast majority of model release has since been then, we're not even going to tell you about the data. So, so everyone's been comparing models that don't have their data open. So things have stopped being that move has stopped being contentious as well. Yeah. I was just sharing him like one of the history is like in the past, because the whole topic of pre-training and how the data set now these days we optimize it more. One of the issues that was faced was like last time when we used to always just do PAL first, then we optimize later. But people started releasing all the models started being, we don't tell you what we put inside. Then that has stopped being an issue.
Go ahead.
Yeah, one possible cause is that sometimes you have too many data. You do not do it systematically, just like Omo did. So maybe sometimes it is not that. It is hard for us to express it, to the whole world. So we just don't say it.
Indeed.
But we try to. Go ahead.
Just before you dropped off, we're talking about the challenges that you guys face, whether GPU rich, GPU poor, hiring, or other things. So you were saying, were you saying hiring was one of the main challenges?
Yeah, I think hiring is always the biggest challenge for almost, from my perspective, for every company. If you have talents, you will have GPUs, you will have the money, because they are really the talents. So that might be why AI is hiring so many talented people, and OpenAI is hiring so many talented people. And for Chinese companies, a little bit harder because we are not international enough, so it is a bit hard to hire foreign people to our companies. You will find that for the Chinese team building large language model, there are always a lot of Chinese guys and no one in other countries. But for in the United States, you will find that there are a lot of people with different backgrounds, with a lot of diversity. That is actually quite important from my perspective.
Oh, why? Because you have basically people with like different kind of like viewpoints on the language and like how with different viewpoints from users? Is that why?
I'm not sure. It might be about culture and some country. I don't want to talk about the country issues, but for the culture and for the languages, there are a lot of people living in China. Foreign people are not that much from the proportion perspective, and a lot of people are speaking Chinese. For example, if a lot of companies, people are speaking Chinese, not speaking English, it is a bit hard for foreign guys to get involved in. So somehow, I think it needs some time to 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 realize this goal. I think Singapore may be a good case. There are a lot of people with different background. Yeah, together.
I mean, it also can be things like, for example, like if you accidentally make mistakes in the tokenizers, you made some
Yeah,
simple data filtering mistakes,
yeah,
and then it starts going to the training. These things get caught faster when someone happens to know at least some basics of the language. It doesn't necessarily need to be. I don't need a native Japanese speaker, for example, but because we had someone who really likes anime and happens to know some basic Japanese, it's like, hey, I think we messed up the Japanese filter here. Same thing for Chinese, English, Spanish. The list can
yeah.
go on and on. So having diversity, just have more eyes on the on different surface areas. That's it.
In terms of like, so I think in the US you can see kind of like Google and OpenAI and Meta and X now are all competing. Like on the Chinese side, is there besides Alibaba, like which are the other firms you would say are heavily competing against each other?
Um, The competition is a bit hard to say. For the large companies, they are building large language models, and like Baidu and Tencent and ByteDance, they are building their large language model. And there are a lot of startups, like just as I said, the GLM team, Zhipu, and recently DeepSeek, Yi, and they are actually quite popular. But I think the competition is actually making the models better because the community
I
are
see.
actually enjoying the benefits. Yeah.
I see. That's great. And I think one of the other interesting things is how much attention do you pay to things in production, right? Like, so one of the things is like, a lot of model builders focus on this kind of training, pre-training, etc. But then once
hmm
things are handed off to production, they're like, you know what, I'm done, and then like move off, right? So how much like attention do you pay to things which are happening in production, whether those things actually have to impact your model builds or etc. going forward?
Yeah, that's a good question. And at the beginning, we pay a lot more attention to it. Yeah, because we only have our own product, and the product is just at the beginning, and everything is new. And
Yeah,
you're building a large language model, and you don't know how to build it, and you are at the same time you are building a product. It is a very painful experience for a lot of people. People are trying to help you, but they don't know how to do. So even if you have a lot of people, you don't know how to do it. This is why I love open source, because you can separate things. For example, for these teams, today we have a very clear goal. Yeah, reaching a good performance general purpose large language model is good for everyone. So you just build it and open source it. Yeah, and hear the feedbacks. If you just mix the production side effect, that will be a very very complex. For example, there are a lot of problems that are caused by your, for example, deployment. Your deployment has some problem, but yeah, it is very hard to yeah to distinguish the problem. So for me, I suggest, yeah, we separate things, but we can find a way to cooperate together. But no, don't just let the model builders to take too much consideration. A little bit is good, but uh, too much consideration for production is not that good. I can understand their concerns, actually. Yeah.
yeah. Eugene, what as the only other person I know who has actually deployed a ton of stuff in production, like, so what is your opinion about that?
I mean, it's slightly similar in the sense that I think I shared previously. Like, you can see model weights decision being heavily reflected by the production end goal. So, why 7B is particularly popular is because the goal is to deploy on consumer GPUs. Why 70B is popular is you can squeeze it with a little bit of quantization into a A100, H100. And why things in the middle are not so popular because 48 gigabyte GPU cards end that common. So you don't really benefit much from having something in the middle because you're only catering to a very small group for deploying. And 3B is for mobile phone devices, generally speaking. So 3, 4, give and take. And these are all consideration that we also do on our side. And it's exactly the reasons why we do these models. Besides the 0.5B and the 1.5B, those are just for experiments and for science, essentially. So very similar statements there, actually. Yeah.
Right on. So I think Matthew Berman on YouTube is probably going to have a. He just said it might Qwen2 might be the Qwen. I keep saying Qwen, but anyway, might be the best open source model I've ever tested. So definitely, I think a lot of excitement, and I think we're all looking forward to seeing like more development from the Qwen team. And also looking forward to seeing from the RWKV team as well some more interesting developments. Thank you guys for taking the time with me today. Very, I learned a lot. Like I really learned a lot today about model construction and some of like the fine tacit knowledge that I think you guys have deployed in building out these products. So thank you so much for your time, guys.
Yeah, thanks for having me.
Well, as always, glad to be here.
Emergent Behavior is a part of the Turpentine Network. For our full newsletter, visit emergentbehavior.co. For more Turpentine podcasts and sponsorship inquiries, visit turpentine.co